How's it going, everybody? Thank you very much. Real quick plug for Codesmith. My company actually just hired somebody who graduated from Codesmith. That was a couple months ago. It worked out great, so highly recommended. So today we're going to talk about load testing, which is also known as denial of service attacks. So anytime somebody asks you, hey, can you beta test my app? You can say, yeah, I actually can do more than that. I can help you destroy it. So a little bit about me, my background. Been coding since the original Game Boy, and have been doing startups pretty much my whole working life. I actually met my first investor at a racetrack. We did 200 miles an hour without helmets, so I know he was a risk taker. And so that was kind of a good profile, and we meshed, and anyway, started a company. So load testing. Of course, what is load testing? Dave gave a pretty good introduction to it, but basically it's about finding that limit and then pushing past it and seeing what happens. So we try to simulate all kinds of user activity, some normal, some abnormal, and apply stress on the application or the REST API or whatever it is until that moment at which it all just comes crashing down. And sometimes it degrades nicely and smoothly. That never happens for me. It always just sort of flips a switch and then it just absolute meltdown. Sometimes it takes the database down with it. So all kinds of fun stuff with load testing, but we're definitely going to learn a little bit more about how to use it, I guess, effectively, and how to use it in a way that can actually help things move forward instead of just taking them down. So in looking at what happens under load, you have a couple different things depending on who you talk to. Talk to us, talk to the engineers, the developers, and all of that. Then there are technical limits. You know, does it crash? Okay, it crashed. Well, how quickly can it come back up? If you take down a database under load, it could take a second for it to come back up for various reasons. Does the experience of the app degrade nicely, or does it again just sort of melt down? Does it errors start popping up, pages start taking really long to load? Depends on what it is, REST API, website, whatever, or an app, mobile app. But there are a lot of things that can happen technically. But then when you look at and talk to the business guy, there are much more serious impacts, seemingly, like, how many customers can we handle? If we get more customers than that, and then the site crashes, do we lose the last half hour of orders, which could be a lot of money, especially when you're handling a large volume of users. So for example, if something were to crash on Black Friday and you lose, let's say half a day of orders, that could be a quarter of the orders for the whole year. So obviously you need to make sure that doesn't happen. And then assuming that you can figure out what happens, how much does it cost to actually fix it and reinforce it and get it ready. So some of the goals that we're going to focus on, or some of the, I guess, the intent of load testing really is to gauge performance, to assess reliability, to figure out scalability, whatever that means. That can mean a lot of different things to a lot of different people. And in some cases, it can mean capacity planning. So figuring out how to handle that volume, how to handle those spikes in traffic. Are we prepared? Are we confident in our system? When we test a little bit on a local machine, does it already start to exhibit strange behavior under load? And so you put it on a production system, and then it's just not going to happen. So some of the metrics, some of the magical numbers that we're going to track with all of this, latency, that's a big one. And that's a good indicator, as you'll see in a graph a little bit later on. Requests per second, this is kind of one of our magical numbers, is how many actual users simultaneously, or really requests simultaneously, can we take. Now, it's possible for users to generate multiple requests per second, then that's probably a problem in the app. Shouldn't be doing that. But response time, how long does it take when they hit a request to the REST API or to whatever, to the website, how long does it actually take for a response to come back? And again, you want to get that in a nice sweet spot. And when it starts to degrade, you're going to see that response time just slowly climbing up until it hits infinity. Percentiles, that's probably a little bit more specific in terms of how you actually look at these different numbers. Now, I wanted to throw out just some ballpark numbers for requests per second and latency. Now, again, everybody is going to have their own opinion about what these numbers should be. I would say that for a mid-sized cloud instance on Amazon, like a medium or something, you should probably expect somewhere around 1,000 requests per second for whatever it is, and maybe 20 millisecond latency, 30 millisecond latency. So when you're doing all your load tests, you start looking at the numbers and you're not hitting that with a medium or maybe a slightly above medium, then you should be concerned. So we'll also take a look at some product services. I should be getting paid by some of these companies. There's one in particular, although it's, I guess, an open source project. So it's the one I really like, and I'm going to show you how to use it. But here's some of the other ones. Here's some of the paid ones, which, has anybody used any of these, by the way? Quick show of hands. OK, a couple people. Loader, Blitz, Soasta, I don't know, Microsoft. Microsoft is actually decent. I hate to say it. It's pretty good. So Flood, I haven't used that one yet, but we tried a bunch of the others, and we had mixed experiences across the board. So we looked at some of the libraries that were available. Apache Bench, which is kind of the, I guess, original workhorse. I mean, everybody used to use that back in the day for simulating traffic. And then Artillery, which is a little bit more modern, but a lot of the same concept. We really like Artillery. That's what I'm going to get into on this one. And then WRK, which I guess is yet another flavor. I hate Apache Bench. I hate it with a passion. It's so confusing, so difficult to use. Artillery is just great, though. So we're going to talk about Artillery and not Apache Bench. So it supports multiple protocols, scriptable, extensible, has a lot of different ways of looking at metrics and a lot of different metrics also. It's integratable into a bunch of stuff, so it's really nodey, really gulpy, adjectives that work in this audience. And it's pretty good performance. I mean, definitely able to take down pretty much every server with it, so that works. So to install it, quite simple, quite straightforward. And then to test it, Artillery Dyno, I don't know, sure. They have some dinosaur thing, sure. So another thing that I would say that it does not come with out of the box, or at least it didn't when we were testing and using it, were like real-time monitors of your app. So looking from inside the application or inside the API, what's going on, and then crash reporting also. So figuring out if your thing does crash and burn, how did it crash? Was it file system related, network related, something else, CPU, a memory, it ran out of memory, which is a common one. So figuring out what exactly happened, Artillery is not going to tell you that. It will just destroy it. It's up to you to figure out how it broke. So fair warning about that. So this is probably the simplest test. If you mess with these numbers a little bit, you should be able to put a lot of stress on whatever is at myapp.com. So replace that with yourfriendsapp.com. And this specifically will put 10 virtual users every second, making 20 requests each for about 60 seconds. So for about a minute, it'll do a small little bit amount of load. Here's a more detailed one. And so you start to put them into scriptable files, and this is where you can start to put them in a version control. You can start to roll them inside of your code repository, et cetera, et cetera. You can set up these scenarios where you have sort of a scriptable behavior, almost simulating what a user is doing and how they're doing it. So you can start to put in specific requests to specific URLs. You can also have it, their phases term is how you can have it ramp up in number of users, ramp up in number of requests. So you can simulate a little bit of people, entering, pinging a few services here and there, and then all of a sudden, a lot of people hitting it. And then you have flow, which is, again, more of the setting up of the scenario. So this is kind of the nuts and bolts of how to set it up. But this script right here that you see up there is probably the simplest representation of actually making a load test. So it's quite easy. So I'd recommend, if nobody's doing it, or if anybody hasn't done it yet, you should probably give it a try. It's really quite easy. At least it's easy nowadays, and you can really simulate a lot of user behavior. Some of the best practices, and anybody can agree or disagree with this, have a little warm-up period. So that's something that doesn't really make sense logically when you think about it. I mean, it's an application. It doesn't need to warm up necessarily, but when you think about it in a production environment, maybe you're warming up your caches, you're warming up, I guess you could be physically warming up the machine as it's first booting, but anyway, virtual machines, never mind. So then you really want to ramp it up. Then you've got your cruising period where you've got a fairly moderate amount of load, which is maybe at your breaking point. And then you don't always see a crash test in a lot of load tests. I always like to add one. It's just very satisfying to just finish it off, You start it up and then you just take it down. So yeah, in this particular instance, a couple of the numbers, maybe the ramp up period is 100 users every second. Cruising is maybe 100 users for a good 20 minutes. And then crash is like 1,000 users for a minute straight, and that'll probably take it down. So this is kind of what happens when you run Artillery. You put it in there, you put in your services, your paths and all of that, and you actually run it, this is what it's outputting. So pretty, not pretty. There are many different ways to report on what's going on. So we'll step through a little bit of the terminology on this one and what you're actually looking at. But at the end of the day, you can generate charts and stuff with it, which we have one of those coming up. And those are actually pretty. This thing, whatever. But anyway, so scenarios launched, scenarios completed, number of requests per second, latency. Codes, this is a really important one. So these are the HTTP response codes. Let's say you're load testing a REST API, and you're getting a lot of 500s or 502s or something like that. Your web server is starting to act a little funky. Maybe you're getting timeouts. What is that, 504? Does anybody know HTTP codes in here? 504? Okay, good. So if you're getting a lot of 504s, then you're probably starting to reach that limit. So and then you've got requests completed. If that's a good thing, the more you see of those, the better. So, okay, let's look at it on a graph. This is a little bit more interesting. And so what we've got here is response time is in green, the green little boxes. Throughput is blue. So that's sort of what you're handling. And then you have failures in red. So if you look closely at this and you look around 128, that's complete meltdown. It is finished. It's over. It's not coming back up. But if you look back a little bit, so you're almost looking at this and then reversing time. If you look back a little bit, you can actually see that there are indicators that this is about to happen. So conceivably, you could add some sort of intelligence into your application that when you start to measure this kind of failure condition, you could either throw an alert, you could execute some other script, you could target an auto-scaling piece of logic or something like that. You could really start to react or preempt the crash. Now that's perhaps a little bit, maybe it's not realistic in practicality, but it is certainly possible. And so if you add those hooks in there and you have a little bit of awareness or intelligence in the application, you might be able to prevent it from crashing under load. So if you look back over under 32, so probably around between 16 and 32 is where you start to see the latency and the response time is climbing up a little bit. It's been pretty steady up until that point, but now you have your minimum response time is starting to creep up. So, and it never really recovers. It never really comes back down. And then around 64, you start to get these 500 errors, these HTTP errors, and then, of course, just crash and burn at 128. So this is a good way of just looking at visually what happens to an app as it hits load, or what happens to a REST API. So this is what your friend's weblogs will look like after you load test it for him, or her. When do you actually do this? This is certainly contentious, but you have beta testing periods. That's probably when I would recommend doing it. Maybe pre-launch, you do a heavy-duty load test. You could even load test your production system. We do that sometimes, so we try to take down our own live website. My business partners don't really like that, but what are you going to do? Major product releases, right before a product release, we'll try to do the same thing. Maybe on holidays when the user traffic is down low. There's always that one guy who's up until like 9 p.m. on Christmas on your app when you're trying to do a load test. So you just give them a little Christmas present of sharing the site with 10,000 virtual users as we load test our January deployment. So that guy, whatever, too bad for him. He'll come back, they always do. So what do you do next? In terms of load testing and where do we go from here? Well, some of the other capabilities of artillery, back to the commercial for artillery, is you can load in external data. So you can have a CSV file with maybe a bunch of product IDs. Maybe you export that from your database and you load it in here. You just kind of specify a link to that CSV file. And then what it'll do is it'll pull a random number from that file, a random line, and pull a random number out of it, and then be able to plug that into the link. So if you remember back a couple slides to where we show that YAML file with the configuration of the test, you could just specify, product ID dot whatever, or API/product/product ID, and then say, hey, and use this CSV file, and then you can have somebody else kind of updating the CSV file or whatever, and you've built that load test, and you can step away, you don't have to come back to it, and it'll always sort of plug in those values from that list and be able to test against actual endpoints with actual values. Where this comes in handy is when you have a production environment and let's say a dev environment or a staging environment where you have maybe different product IDs. So you want to do some testing, but you don't want to accidentally hit and test maybe the live server or something like that, so you have different product ID sets anyway. Replicating user behavior, you can look back through weblogs or something and start to piece together how somebody traversed through your application, and then you can load that into those scenarios and those phases back in that YAML or JSON file, so you can actually simulate what real user activity was, or in some way, now this probably takes some scripting, but you might be able to take a weblog as an input and then create a load test out of it, so that you're replicating almost like a Groundhog Day what happened that day. And if it was a day that your thing crashed, I mean, it's almost like playing back history again and again, and you can watch it, then you can make a few adjustments, play it back, and then really solve it retroactively. So kind of exciting in that regard with being able to actually apply this practically to some problem. So you can also start to integrate it with OAuth and with that whole flow. So it has the capability of incorporating custom headers and headers generated at runtime, et cetera, et cetera. Very nice with regard to that. So automating it with continuous integration. So let's say you do a commit to the repository, you could conceivably execute a load test right then and there. I'm not sure I would recommend doing that, because if somebody's committing and they don't really realize what's happening as a result, maybe you have somebody on the team who's a little commit happy one night and just commit after commit after commit, and then of course you're taking down your server every time if you have that crash scenario built in there. Monitoring live activity, so that's something I kind of mentioned at the beginning, is figuring out what is actually happening inside the application, not necessarily what's happening at the load tester. So the load tester is simulating a client, pretending to be some regular user, but then you also have, of course, the application itself. So you almost want to watch on both sides. You know, it's like being on both sides of a battle, and you want to see how it's going down. So those are pretty much, that's where I would take load testing, and that's where I would recommend taking load testing when you want to take it to the next step. And of course, it gets even more complicated than that, but that's pretty much, that's load testing in a nutshell, and using artillery. Very easy to get into, and very fun to watch as something just comes crashing down that you spent 6 months building. So thank you very much. Any questions?
If you work at a company that does not currently do load tests, if you're an engineer, how do you convince people around you that this is important?
There are a couple answers for that. Number one is you could do it one day, and then the site crashes, and you say, you know, we really should have load testing so we can see that coming. Just cover your tracks and delete your log files. But no, I would say that if there's no way that they can't understand the concept behind it, the concept of stress testing, I mean, it's a fundamental engineering concept. There are entire disciplines of physics and engineering built around stress testing and fracture points and all of that, and people do it for building bridges. So you could make a bunch of silly analogies to them, like, hey, before we build this bridge and install it between us and the customer, we should really take a bunch of vehicles over it and see and make sure it doesn't collapse. But I would say the number one thing, just tell them that there's money. You know, that if we crash and we lose a bunch of customers, or customers are unhappy, we lose a bunch of transactions, it's going to cost a lot of money, and it's really cheap now if we do it. Some combination of these anecdotes will perhaps influence somebody, but I would probably just do it and then ask for forgiveness afterwards. Questions? Yep.
Yeah. How expressive is the configuration language where you send over some JSON, the response can be different, and you don't know how to respond to that? Maybe you still program it's very static.
So the question you're asking is, if you're sending a request over to your server and the response is a little bit dynamic, how does it?
And you want to use that for the next request. It's not known for what.
You're going to be writing some code for that. Yeah, I don't think that that's necessarily one of the primary use cases. It's probably more to see how that endpoint would respond. But I see what you're saying. I mean, in terms of following user behavior, if you wanted to make it, let's say, pick a random item from a list that comes back and then visit that item, I believe there's some level of randomization for picking out responses in a JSON or picking out lines in a JSON response and using those as variables in the next test. It does have some capacity for that, but you may end up having to write some code.
How to generate that pretty report?
Oh, the graph? Oh, they actually had it on their website. No, there's a specific reporting tool that they have that will create those sort of load graphs. I can't remember the name of it. It's linked from their website. So that's probably there. So you've got the JSON output that it produces. You've got the text output that I showed on the screen. What these reporters will do, and if you've ever used something like Mocha, or that's a testing framework, that also has these sort of pluggable reporting tools that the normal output is really kind of ugly and texty and console-y, and when you want to show it in a pretty graph, you need some kind of translation. So it's just JSON output that you could graph with anything really, but they also provide some graphing tools, some reporters. So it'd be a custom reporter, visual graphing reporter, and they would have it on their website linked.
Any recommendations or possibilities for doing this without running it on production?
Yeah, I mean, I would run it inside of a sandbox or run it on a local host. Now, the trick with running it on a local host is you're probably going to want to have two machines, or two virtual machines, I would say, that you don't necessarily want to run the load tester on the same machine as where your actual app is or where your service is. The reason being you can actually run out of network handles. Depending on your operating system, you can run out of file handles because you may only be getting a number that's about half of what your machine is capable because the load tester itself is using quite a number of resources to hit your server. So that's what I would say is you will probably end up wanting to have two machines next to each other, or again, load testing your friend's machine and then having them load test yours, something like that. But yeah, in terms of avoiding production environment, make a copy of a production environment, do it on there. Any other questions? Oh, same person. Sure.
I noticed on the throughput graph that it went slightly upwards. Even though you went, you're hitting it more often, you're doing more requests. You notice that on the trend line?
Yeah, let me run back to it real quick.
This still anomaly at the 128 to 56 going up.
Well, I believe that's response time. So it is going up. I mean, it's kind of impressive that it's even responding at that point. So I think that, oh, are you talking about the blue line? Okay. Yeah, what's happening is it's not really capable of delivering any more throughput. So you have a little spike there around 128 where the server seemingly recovers for a second and it's able to queue up a lot more requests, but then that queue of requests overloaded again because it's still kind of crippled. So it hasn't fully recovered from the load that it's experienced up to that point. So that's why you want to do this continuous load on it, that kind of a test, because you will see it. It could take 5 minutes of load for something to eventually dip down and crash. It may not be very straightforward. It may not crash instantly. It could take a little bit. And that's just the side effect of, it could be memory allocation. It could be just never able to really catch up. And then it just eventually sinks. But yeah, that would explain that, is it just kind of crashed and then it seemingly recovered and then it's trying to stabilize maybe at a lower point, but it'll probably just crash and come up again for a second and crash again. Okay.
As far as load testing, are there any differences between like actual infection and DDoS attack in terms of what you're simulating?
DDoS attack is probably going to come from a lot of different machines, and it'll probably have a lot of different kinds of attack patterns. So I would say in structuring a load test or understanding the difference between them, a load test will look like a load test unless you try really, really hard to make it look like a DDoS attack. And to make it look like a DDoS attack, you're going to have to use a lot of different machines, probably from a lot of different places in the world. So now you start getting into network configuration too, where that's going to be a big variable. I would say that this load testing, that what we would use it primarily for is testing a service in an isolated environment, testing it in a sandbox. What we're testing is not our network configuration. We're testing the server response code, the API, the REST API, whatever it may be. We're testing how that handles load, not necessarily attack patterns of DDoS. That is a kind of a separate topic, I would say, more towards security or network infrastructure, less about code optimization. You can always optimize your code to avoid that. What I would say is one of the things you do with preventing DDoS attacks is you probably start to look at patterns of traffic and start to throttle down the network side of it, prevent those requests from ever getting to the server. And this would be more for, well, what happens to the requests that actually do get through? What is that failure point?
You use it in concert with something like Chaos Monkey, where you're actually simulating network or physical server failures?
No, we haven't been doing that. That's the next step, really. So once we figure this out and we get our app seemingly working, then we put it on, production hardware, and then all of a sudden, we realize that, oh, well, now we have to deal with network optimization. So yeah, that's the next step. That would be part 2, is now that you've done this and you think you're done, you're actually not done.
Sorry, one more, I guess. On the application monitoring side, you sort of alluded to it. Are you using Splunk for log management, Logly, New Relic? How are you actually doing it from the application side?
We've tried a bunch of those different tools, and they all have their pros and cons. We ended up doing something that was effectively reporting through WebSockets to a central ops dashboard that does the reporting built into that. So it's not necessarily the most conventional. It may not even be the best way to do it by any capacity, but we effectively have a live connection between our servers and kind of behind the scenes ops server. And once that connection is fuzzy, we don't really care what happens to the machine at that point. If it can't report its logs, then it's going down, and we kind of reroute traffic around it anyway. So.
Okay, give it up for Jad.